Hey, what's up, everybody? Welcome to wireless, the wireless networks. Yes, wireless is one of the last chapters in volume 1 of your book. This is going to be a complete wireless course because I'm going to make it a complete wireless course. Okay, you're going to notice a whole bunch of things. Now, when you're looking at the presentation of what's going to be given, all right, do not be surprised that the next lecture doesn't follow what the introduction says. Okay, because I may have, oh, okay, let me put this in. Oh, wait a minute, I forgot this. Let me put that in. So, but this is just a basic, I'll say it that way, a basic introduction to the things that we're going to cover in wireless. So I'm going to leave you with the recording, right, the lecture of what we're going to be going over, but it's going to be a lot much more than that. Okay, just be ready. All right, wireless is the wave of the future, right? We're not getting any younger. We don't want to run cables anymore, right? We want to run wires. Well, I mean, be wireless. All right, so that's just the way it is. So again, the introduction to the wireless area network. I'll see you in the next one. Welcome, everybody, to the wireless LAN, right? The wireless LAN section of volume 1 in your Cisco CCNA 20-301. Yes, they have wireless in all its glory. All right, so we'll be getting into a lot of detail of wireless LAN networks. So let me just go over the things that we're going to talk about in this particular section. Now, one of the first things that we need to understand is not only the devices, obviously, that work in wireless networks, but LAN topologies. Just like you have an Ethernet, right, which is 802.3. This is 802.11 for wireless, and there's different, and we'll get into the different 802.11 A, B, G, and A, and AC, because really AX it's out, but hey, I doubt if anybody's using it yet. But when we get there, we'll talk about that. But topologies you need to understand because you could be doing independent server sets, basic server sets, extended server sets, distribution types of topologies where you're going from wireless to wired, and things of that nature. So we'll be talking about wireless LAN topologies. Radio frequency standards, right? One of the main two that we use is like 2.4 gigahertz and 5 gigahertz. We're going to be talking about the different channels that exist in those RF standards. And there's some controversy in there that I found as far as the non-overlapping channels in the 5 gigahertz range. All right, so we'll take a look at those frequencies. We're going to discuss them at length, okay, and see which would be the best ones to use and which are the real non-overlapping channels. Now, we also need to understand the signals and modulation. We know that radio frequency signals, there are cycles, all right? There are wavelengths. And the modulation is the intelligence that we put into those wavelengths, depending on the actual radio frequency that you're using, and the modulation that you're using will determine how clear and how long, meaning how far, I should say, how far you will actually get your signal from point A to point B. And that's why radio frequencies in the real world, because we'll talk about interference, the different types of things that happen to these signals when they start hitting objects. And just to mention, some basic words with interference, diffraction, refraction, deflection, scattering, all these different things, absorption, that happens with RF signals. Again, depending on the radio frequency standards that you're using, are they using overlapping channels? Okay, all these different things, the power, because there's one thing that, yes, it will be math here. Okay, not that big of a deal math, but there is things you need to understand about the effective isotropic radiated power. All right, not EIGRP, but EIRP, effective isotropic radiated power, meaning the strength. where the signal comes out of an antenna, depending on how you're sending it. So there's a lot of things with wireless that we really don't have to worry about it in wired. We worry about interference, obviously, but depending on the type of wired cabling that we're using, twisted pair cabling that we're using, or we're using fiber or coax, we can see if we have an interference or not. If we're using Cat 6, Cat 7, that has those twisted pairs and that spine or spleen that they call in between, something like that, that separates, that plastic separator of the cable, so we don't have any crosstalk. So there's ways in wired networks that we use to minimize interference. Well, the same thing in wireless that we can do to minimize the amount of interference and to extend our wireless networks on how far that we need to. So that's where antennas come in. Antennas. All right, there's different types. There's directional antennas, omnidirectional antennas. There's all sorts of antennas, and now we always know the good old can antenna, right? That made up with a Pringles can. But now they actually have can antennas that you purchase at stores, and there'll be more of a directional antenna where you can. It'll be very narrow because you're going to have to understand that there's things called lobes and the way that the signal actually radiates out of the antenna, because understanding that will be the best way that you will avoid interference. And when we get into these different things, we'll take a look at all these cycles and all these frames and how these this frequency, this being pushed out of this antenna due to the power that we're pushing through there, how far is it going, how is it really going. And so if we do have our APs, our routers, our wireless controllers, which direction should we point our antennas, and all these different things. So we need to understand. And then we get into the frame types of the actual 802.11 and how they work. Because in wired, we have CSMA CD, collision detection. In wireless, we have CSMA CA, which is avoidance. So we're going to talk about the frames and clear to send, request to send, all these different things that exist in wireless, as well as the coverage. The coverage, because we need to know, we need to be able to extend. And this is where the radio site survey and the physical site survey come in. All right, so when we go, somebody calls us, let's say, hey, I want my company, my real estate company, my law firm, what hospital, okay, I want it to be wireless. And every hospital you go to now, they have wireless everywhere. Pretty much everywhere they have wireless now. You need to understand what type of antennas you're going to be using and the type of power that you're allowed to put through there, because the more power you put through a wire to push out a signal, that will determine the frequency that you're in. All right. So you can be very easily overlapping with somebody else's proprietary signal if you do that. And that would be called piracy. All right. It is the FCC. When we talk about standards, the FCC is the one that regulates all these things. And then we'll learn basic wireless security fundamentals like we would normally do on a wireless router. But we'll also talk about radius in there. We'll talk about EEP, LEAP, PEEP, all these different things. I always find that funny to say that. All right. But these are very serious things, because wireless, one of the things that wireless does do is really open the door to people coming in and getting into our network, because we really don't pay attention because of the way that is advertised. Hey, just buy this router from the store, plug it into your network, and boom, you're up and running, you're up online, you can do whatever you want. But the thing is, you're not secured, and people, your neighbors can be using your wireless to get to the internet, and they don't have to worry about paying for internet. They just use yours. So there's things that you at least do the basics of it. You can do it. I don't think anybody's going out there in their house and setting up wireless controllers. That there's different types of wireless controllers and architectures that we can use when using controller-based deployments, which is really in a large enterprise network, the best way to go. Just like in wired networks that we have the software design network, right? That APIC controller, whereas everything is centralized. this is pretty much the same thing where the controllers are the central point of the wireless network. Everybody connects to the AP connects to the wireless controller. The controller sends them all the configurations, all the updates. Controller's connected to the router, takes them out to the internet. Everything's, in one location. So implementing wireless-based controllers is the way to go now, because you want everything centralized, just like we're doing with our basic wired network infrastructure. We're putting everything on a controller, which is that APEC controller, okay? But yeah, security will be something that we will be getting in depth, not too far in depth, but we'll understand it. As far as for the certification, it'll probably be an overkill, but you need to know that this is something that you need to do in a wireless network, because you're so vulnerable. You're vulnerable as it is in a wired network, because once we get online, that's it. You know what I mean? If you haven't hardened your computer, you don't have firewalls, you don't have your Windows firewall on because you don't like it, whatever the case may be, you're wide open for the world to come in and take your stuff. Even though you may not be, a huge company, or, you're just a regular everyday individual playing games online, you will be hacked just for the hell of it. All right, so don't make it easy, because security is all about layering. I've said this in all my classes. Security is about layering, and that's what we'll talk about here. But in a company, obviously, we have different ways of doing it, where we have PKI, we have using those wireless certificates for wireless users, and then we have the radius or TACACS, whichever ones you want to do, and the protocols that I mentioned, like EAP, LEAP, and PEEP, that we can use as well. And then obviously using controller-based deployments to make your life a lot easier, to make it more automatic, where you just update the controller and then the controller will update all the APs. All right. So all these things we'll be discussing in this wireless section, starting with wireless LAN topologies, but that will encompass also the devices that we're going to use that make up these different types of wireless LAN topologies. Cool? All right. So get ready, strap on, because there's a lot of wireless information coming your way. I'll see you in the next one.